Overfitting is a phenomenon that occurs when a machine learning model is constrained to training set and not able to perform well on unseen data. Regularization is a technique used to reduce the errors by fitting the function appropriately on the given training set and avoid overfitting. The commonly used regularization techniques are L1 regularization, L2 regularization, and dropout regularization. This video focused on L1 and L2 regularization. A regression model which uses L1 regularization technique is called Lasso, least absolute shrinkage and selection operator regression. A regression model that uses L2 regularization technique is called ridge regression. Lasso regression adds absolute value of magnitude of coefficient as penalty term to the loss function. Ridge regression adds squared magnitude of coefficient as penalty term to the loss function. A regression model that uses L1 regularization technique is called Lasso regression, and model which uses L2 is called ridge regression. The key difference between these two is the penalty term. Ridge regression adds the squared magnitude of coefficient as penalty term to the loss function. Lambda is 0, then you can imagine we get back to the old linear regression model. However, if lambda is very large, then it will add too much weight and it will lead to underfitting. Having said that, it's important how lambda is chosen. Then technique works very well to avoid overfitting issue. Lasso regression, least absolute shrinkage and selection operator adds absolute value of magnitude of coefficient as penalty term to the loss function. Again, if lambda is 0, then we will go back to the OLS, whereas very large value will make coefficient 0 and hence it will underfit. The key difference between these techniques is that Lasso shrinks the less important features coefficient to 0, thus removing some feature altogether. So this works well for feature selection in case we have a huge number of features. Traditional methods like cross-validation, stepwise regression to handle overfitting, and perform feature selection work well with small set of features, but these techniques are a great alternative when we are dealing with a large set of features.